Hi everyone. Thank you for joining me today. My name is Yashraj Chudasma and I'm here to present a demo tool InterpretME. This tool is designed to enhance the interpretability of machine learning models. Today, I will walk you through its features and show you how it can benefit you and semantic web community. Let's start with a quick overview of our tool. As you can see on the screen, the title of our tool is InterpretME, which is a powerful solution that simplifies the machine learning model interpretability. Following the FAIR principle, InterpretME is available on Zenodo, PyPy, and GitHub. The following GitHub repo contains the code for demonstrating InterpretME. Now let's jump into the live demo to see the tool in action. To get started, you can first clone the repo by executing the following command. To run the demo, there are two options available. You can directly click on the binder batch and run the entire demo. Just as the information, binder server sometimes might take 5 minutes to load the entire demo. And second option is about running the demo locally. You can execute the following command in your terminal. This will start the Docker container, then navigate to the following link and to see the demo live in action. InterpretME is highly motivated by a hybrid design pattern. As you can see on the screen, InterpretME is composed of 3 layers: train, deduce, and explain. We propose a tool that integrates the data either from the knowledge graph or data sets and aim to exploit the semantic information and provide the user with more meaningful and trustable interpretation. InterpretME was utilized over French royalty benchmark. Just a short glance, like French royalty benchmark is a fully curated subset of a DBpedia and represents the French royal family. Following are the statistics of the knowledge graph. InterpretME as a library offers following modules. First and foremost, pipeline function, then plot and the federated function. InterpretME takes a JSON file as an input, that is URL of an endpoint or path to a data set, features definition, that is independent variable, dependent variable, SHACL constraints, target class definition, and also if the target class is imbalanced, user has the possibility to provide a sampling strategy to balance the data. Here I'm going to demonstrate how InterpretME pipeline works. As you can see on the screen, I have already set up the necessary inputs. The purpose of the pipeline function is to assemble several components of InterpretME to generate InterpretME knowledge graph. This feature saves time and effort for the user. Now I will demonstrate the following use cases. Firstly, unveiling important features. Here, user will observe the most important features. Executing the following SPARQL query over InterpretME knowledge graph helps to retrieve the most important features of a target entity, for example, Louis 14. The output of this query are the features and the contribution of these features for the predictive task, which is been interpreted by LIME. Now, let's look into another use case, insights beyond numbers. This use case presents a SPARQL query over the federation of InterpretME knowledge graph and the input knowledge graph, where LIME provides the interpretations for two entities, while both entities in the input knowledge graph present the same concept using OWL same as. As we can see, the output of this SPARQL query shows that LIME generates different interpretations of the entities while they are same. Thus, InterpretME highlights the significance of considering semantics inside the model. Next use case is validity of a target entity. Here, SHACL constraint is essential for checking the validity of the entities in the input knowledge graph. Following SPARQL query demonstrate SHACL constraint and the validation report of an entity. The output of this query will assist the user on interpreting ML model decision for entities that violate domain constraints. Lastly, we will like to demonstrate the use case opacity to clarity. Here, a federated query engine named DeTrusty is utilized to answer the user's questions via SPARQL queries over the InterpretME knowledge graph and the input knowledge graph. Executing the following queries will provide more comprehensive interpretation of a target entity, for example, Louis 14 in this case, by retrieving the main characteristics of target entity in the machine learning model and in the InterpretME knowledge graph. That brings us to the end of the demo. I hope you enjoy seeing our tool in action and how it can benefit the semantic web community. If you have any questions or would like to explore more, please feel free to ask. Thank you for your time.